Welcome back to my YouTube channel. Today I'm talking about the rgamma function in R. The rgamma function generates random values from the gamma distribution. The first required argument is n, the number of values you want to generate. And the state parameter is also a required argument. It's one of the two parameters of the gamma distribution. The second parameter is an optional argument. You have the rate or scale parameter depending on which parameterization you're using. So you can only specify one of these, and the function automatically specifies the other one. So if you specify rate, the scale is automatically 1 divided by the rate, and vice versa. The rate parameter is set based on what you specified for the scale. So the rate parameter by default is 1, and by default the scale parameter is 1 divided by the rate. So of course 1 divided by 1 is still 1. So by default these are both set to 1, and if you need something different you have to specify that directly. Okay, so I'm going to get started with programming. I'm going to make a vector called x, and generate 1 million samples from the gamma distribution with state parameter 1 and rate parameter set to 1 by default. So if we do a histogram of that, we get something that looks like the exponential distribution. And if we do this again with the rate parameter set 1, and then let's make the rate parameter 2. I'll do a hist of that. I get a new distribution that goes from 0 to 7 compared to 0 to 15 or 14. So it cuts it in about half the range of the distribution. And I can also specify scale. So do this one more time. 10 to the 6. Shape I have to specify, and if I want scale I need to say that, because if I try to do what I did again I'm going to end up specifying the rate every time. I have to tell it I want scale, and I'm just going to do the same thing. So 0.5, 1 divided by 0.5 is again 2, so this would actually be the same distribution as the one before it, and it's the same distribution. Okay? So there's more stuff you can do with this. We can use the simulated value to get proportions. And to do this I'm going to go ahead and make 1 million more. And I'll just do the state parameter. So again, the histogram looks like this, like an exponential distribution. Okay? So I'm going to do a quick simulation to get the proportion above 2. A natural thing you'd be asked to do in a statistics class, but instead of using the P, Q, and D variant of the rgamma function, we're just doing it by simulation. So for I in 1 to the length of x, the length of the x vector is 1 million. So we're saying for I in 1 to 1 million, so I is going to be 1, 2, 3, up to 1 million. So we make a conditional statement. If xi or x of I, is greater than 2, and then we tell the function or the conditional statement to do something. So we count up. Counter equals counter plus 1. So for each value of x that we sample from the gamma distribution, we evaluate if it's greater than 2, and if it is, we count up. So I'm getting the proportion of this distribution greater than 2. And to get an actual proportion, we just say the counter divided by the number of things we counted, the length of x. Okay, so in this parameterization of the gamma distribution, about 0.13 or 0.14 is the answer. The proportion of the value greater than 2, which can be helpful if you need to use the P, Q, or D functions to get the proportion, so you can get an idea if you're in the right tail, because it's a lot easier to think of it in these terms than think of it as I need this proportion of the graph, or I need to do 1 minus. It's a more intuitive way of thinking about it and comparing your answers that are more exact to using P, Q, or D, depending on the problem you're solving. Of course, when you do this by simulation, you're never getting an exact answer. Okay, that's all I had for today, and that's the end of the video. Thank you for watching.